Hello, ladies and gentlemen. Welcome once again to our virtual classroom. And today's video is going to be on subtracting integers. If you haven't done the assignment yet, I highly encourage you, sorry for that. I highly encourage you to pause the video right now, copy down the heading, and then obviously continue once you finish. So today's lesson is found in SB 8-3, subtracting integers. This is our 19th lesson. And just a heads up, if you hadn't done the assignment just yet, I only did 11 and then 14 through 25. So we were not doing 27, 29, or 30, at least not right now. So just 11 and then 14 through 25. Let's begin. So in the topic of integers, subtracting integers. So obviously subtracting or subtraction is the opposite of addition. I'm bringing that up for a reason. I know you guys probably know that already. So subtraction is the opposite of addition in the same way that division is the opposite of multiplication. So those come in pairs. So subtraction is the opposite of addition. And when I'm talking about subtracting with integers, I am referring to this. Up until this point, ladies and gentlemen, you're probably familiar with subtracting things such as like 7 minus 3, or 5 minus 2, or 6 minus 4, or something like that. Now, in each of these different scenarios that I just came up with off the top of my head, notice how the first number was always larger than the second number. Okay, the first number was always larger than the second number. This is what you've been doing up until this point. And that should come pretty easy to most, if not all of you. However, today, ladies and gentlemen, we are going to be talking about what happens whenever you have something like 3 minus 4, or 8 minus 10, or 2 minus 7. And so right now I'm not going to go over these specifically, but something that I'm sure you've noticed is that in the number line, it doesn't just go positively. It is possible to have a number that is less than 0. And so that's what we find in each of these scenarios that I did in the orange. You're going to find that you are going to get answers in the negatives. We're taking more away than what we actually have, if you want to think of it in those terms. And so again, you are going to end up with negative numbers. What's going on back here? Anyways, and so when I'm talking about subtracting integers, remember an integer is a number. It can be positive or negative as long as it does not have a decimal value. This is a little bit of what I'm talking about. Either one or both of the things we're subtracting, numbers we're subtracting, are going to be negative, or the answer is going to be negative, given that the first number is going to be less than the second number. That is what I'm referring to when I say subtracting integers. All right. And so with that in mind, let's begin. Ladies and gentlemen, again, remember, what I'm about to show you only applies to subtracting integers. That is, you're subtracting and one or both of the numbers are negative, or the answer that you would get is going to be negative given the fact that the first number is less than the second number. So again, this only applies to subtracting with integers. We're not adding, we're not multiplying, we're not dividing. This only applies to when you're subtracting. All right. So ladies and gentlemen, when you're subtracting with integers, we are going to change the problem into an addition problem. So we're not going to subtract. We're going to change it to addition. Now, it's not that we are going to change the problem itself. It's that we are going to change our perspective. We're going to change the way that we look at it. I think it's very similar to, if you've heard of the analogy of instead of looking at the glass half empty, look at it half full. That's kind of what I'm talking about. The glass is still the same. It's just a different perspective. And so we are going to change the way the problem looks, so that instead of having to deal with subtraction, we're going to deal with addition, which we already learned how to do. We've been doing that for the last few days, where we're adding integers. And the way that we're going to do that, we're going to follow an acronym that goes like this. It's KCC. That should sound familiar. It is very similar to the acronym that we have for dividing fractions, which is KCF, but this time it's KCC. So we're going to use KCC to change the subtraction problem into an addition problem, and then we're just going to apply the addition rules that we've learned already. Okay, if you don't remember those, I highly encourage you to go watch some of the videos that we have on adding integers. The best way to do this is to just go ahead and jump in. Let's do the first problem in our assignment today, which is -2 minus -2 minus -3, -3. And so again, ladies and gentlemen, as you can see, we are subtracting. We are subtracting. That is very important. If we're not subtracting, then we cannot do this. All right. Now, the first thing I want you to realize is that there's three different elements here. There's three different elements. The first is the first number, which could be positive or negative. In this case, the first number is a -2. The second element is the actual operation, which is subtraction. And the third element that we have is the second number, which again could be positive or negative. In this case, it happens to be a -3. All right. That's why I use three different colors. And again, the acronym is KCC. The K stands for keep, just like it did before. The first C stands for change. And the second C will also stand for change. Let me show you why I'm using this acronym. Keep is pretty obvious. Whatever that first number is, we're going to keep it exactly the same. We started off with -2, and I'm going to keep it as -2. If you remember when we were doing division, we had KCF, the C stood for change. We would change the division into its opposite. The opposite of division is multiplication. So in this case, we're going to do the same thing. We're going to change the operation into its opposite, except that this time, since we're starting with subtraction, we're going to change it to its opposite. The opposite of subtraction is addition. So again, we keep the -2, and then we change the subtraction into its opposite, which is addition. And then lastly, we're going to change the second number into its opposite as well. So I'm going to change the -3 into +3, or just 3. So that's why it's keep, change, change. You can also think of it as keep, change to the opposite, change to the opposite. Keep, opposite, opposite. So keep, change, change. All right, so again, we kept the -2. We changed the minus sign into addition. Again, we only do this for subtraction. And then we're going to change the second number into its opposite. If this was a +3, then I would change it to a -3. But because we started with a -3, we changed it to a +3. Now, ladies and gentlemen, I have an addition problem. And we should know how to do this. We should know how to do this by now. So we have -2 plus 3. Going back to our addition rules, let's ask ourselves, do we have same signs or different signs? Obviously, we have different signs here. We have a negative plus a positive. So we're actually going to subtract those two numbers. 3 minus 2 is going to give me 1. And it's going to be a positive 1 because we have more positive than negative numbers. We have 3 positives and we have 2 negatives. So it's going to remain positive. And that's it. It seems like a lot, but it really wasn't. All we did, guys, is that whenever we had a subtraction problem, which we did, we applied KCC to change it to an addition, and then we just applied the addition rules that you should know already. All right, let's try another one. Oh, by the way, before I do that, guys, I need you to realize that this problem and this problem, these number sentence are actually the exact same thing. All right, I didn't change it. All right, -2 minus -3 is equal to +1. Now, I'm not going to take the time to show you why that is, why they are exactly the same. At this point, I just need you to trust me. The actual why is something that we might cover in the future, but I don't want to risk confusing you. I just need you guys to understand that this is true, that instead of looking at it as a subtraction problem, I'm going to change it into an addition problem that means the exact same thing. All right, moving on. Let's try 11b. Let us try 11b. 11b reads, and I'll do this one here on the side. We have 1, oops, give me 1 second, 1 minus negative 6. Oh, sorry, 1 minus positive 6, actually. 1 minus 6. Okay, for these problems, ladies and gentlemen, in order to show your work, I do want to see you physically write KCC. You can do it either above or below, but I want you to write K on the first element, C on the second element, and then again, C on the third element, K, C, C. All right, K means keep, so we're gonna keep the positive 1 exactly as it is. The first C stands for change, so we're going to change the operation to its opposite. So I'm going to change the minus to a plus. And the second C again stands for change to the opposite. So I'm going to change the positive 6 into a negative 6. Observe how I'm putting it inside parentheses so it doesn't say 1 plus minus 6. No, it's 1 plus negative 6. It's just to show that this is one complete number by itself. It's a negative 6. Now that it's an addition problem, let's go ahead and apply our addition rules. Same signs or different signs? I see that they have different signs. One of them is positive and the other is negative. Therefore, I'm just going to subtract them. 6 minus 1 is 5. And the answer is going to be negative 5, because there are more negatives than positives. We have 6 negatives and 1 positive. Therefore, it's going to be negative 5. Just like that. Let's try number 14 down here. Number 14, we have 1 minus negative 8. Again, I am subtracting, so I'm going to apply K, C, C. What am I going to keep? I'm going to keep the 1. It stays exactly the same. I'm going to change the minus sign to a plus sign because that's its opposite. And then I'm going to change the negative 8 to a positive 8. What's 1 plus 8? Same sign, so it's going to be 9. I'm just going to add them, and it's going to be a positive 9. Notice how much simpler this is, how much easier it is to think about. Yes, 1 minus negative 8 is equal to 9. These two things are exactly the same thing, but the addition perspective is easier for us to conceptualize. Let's do just one more. We have negative 6. Give me one second. We have negative 6 minus a negative 2. Negative 6 minus negative 2. Let's apply keep, change, and change. That's going to yield, so negative 6 is going to stay the same. So we're going to keep the negative 6. We're going to change subtraction to addition. And I'm going to change the negative 2 to a positive 2. Now it's an addition problem. Same signs or different signs? Different signs. I have a negative and plus a positive. So I'm actually going to subtract them. The negative 6 wants to go towards the negative side, whereas the positive 2 wants to go to the positive. So they're going to subtract each other. 6 minus 2 is 4. And my answer is going to be a negative because there are more negatives than there are positives. That's it. Is this simple? Yes. But believe me, ladies and gentlemen, it is also very confusing. It's only not confusing if you follow these rules. If you follow these rules, you're going to be fine. You're going to do awesome. So ladies and gentlemen, I highly, highly, highly encourage you to show your work by writing KCC any and every time that you have a subtraction problem. If you do that, you're going to be totally fine. Okay, that's it for today, and I will see you next time.